Okay, now we want to talk about a special kind of a spring called an artesian well. So what's going to happen with the artesian well is the water, the spring, is going to bubble up out of the ground and actually can shoot up into the air. The reason why it can shoot up into the air is because it's going to be under pressure. So if we were to draw a picture of some water, then the deeper you go into the water, the higher the pressure is going to be. So that when you're up here at the surface, the pressure is going to be basically atmospheric pressure. It would be the pressure of all of this air pushing down on the water. So that would be atmospheric pressure is going to act on the water at the surface. Okay, but if you're down here, it's going to be the atmospheric pressure plus the pressure caused by all of this water that is on top of you. Okay, and so that is going to be, the formula for that is going to be the pressure is going to be the density of the water, rho, multiplied by a constant, which is going to be gravity. So it's called the acceleration due to gravity, because gravity is what's going to be pulling the water down. And then it's also going to depend on h, where h is going to be how deep underwater are you. So that the deeper you go, the greater the pressure is going to be on that water. So let's take a look at this picture over here to the side, which shows some mountains, and then the mountains are going to go down onto the plains. Okay, so it's going to rain on these mountains up here, and then some of that water is going to soak into the ground, and so it's going to go into the groundwater. Now let's say that for some reason that there is some sandstone that is, you're going to have a layer of sandstone like this. So sandstone is an aquifer. So this thing will be able to carry groundwater in it. And so this rain up here is going to get into this thing and it's going to be carried that way. Now, if there is no clay present, then what can happen is that this groundwater could leak further down, or it could go up. Okay, but if there is a layer of clay, so let's now put a boundary here. So now let's say this is impermeable clay here, and then another layer of impermeable clay is located here. Well, then that's going to keep the water confined to this region. Now notice that if we were to put an elevation on this, so let's say that the water goes in right here and is at a certain height. Let's call it h sub 0 for the original height. And then let's say that down here it's deeper. So the depth from here down to here, let's say that that's the letter H. So that this water that is down lower is under a higher pressure than this water that's up here, just like in this picture. Well, this water that's in this pipe could be under so much pressure that if there was a crack to develop, and let's say that that crack goes across that clay layer, and then it makes it all the way up to the surface, well, then this water is going to be squirts up the crack, and then it's going to shoot up out of the ground. And so the height that the water can shoot out of the ground depends on this height over here. So if I was to make a line across, theoretically this water could shoot up to the same height as it is over there. So this is the idea of a artesian well. It's going to be a spring, but the water in the spring is under such high pressure it can be actually forced up to the surface and can shoot a certain distance above the ground. All right, now in our next segment we want to talk about how does a hot spring and geyser work.